Okay, so you asked for more enthusiasm. Okay, so for our review, we're going to talk about circles in this unit. So just a little refresh, we've got a circle, and remember the diameter is a line or segment that goes through the middle of the circle, and then the radius is going to be half of that. So from the center of the circle anywhere out, and remember that radius is always going to be the same distance. Okay, obviously, it doesn't look like it in my lovely drawing, but it is. So all radii are congruent, and same thing with all diameters. Whether you draw the diameter up and down on a diagonal, it's always going to be the same. So if we have, in number one, find the circumference of a circle whose center is at -4, 5, and -3, 7. So circumference, remember, we could find using 2 pi r, or we could do 2... sorry, not 2. Hello, come on. We could say pi d. Well, if I have a circle and I know the center of it is at -4, 5, and there's another point somewhere that's -3, -7, okay, these two connected are going to be the radius. So I'm going to choose to use this formula and just find the radius. Now the radius is a length. So you want to find the distance. So instead of labeling it d for distance, I'm going to label it r for the radius. And I'm going to use the distance formula between the center and the point that's on the circle. So you've got -4 minus -3 squared plus 5 minus -7 squared. And then you're going to simplify this. So the radius equals the square root of, let's see, -1 squared plus 12 squared. Okay, continuing on, you got 1 plus 144, which equals the square root of 145. Okay, so that's the radius, okay, the length between the center of the circle and a point outside. And now all we're going to do here is we're going to substitute it back into our equation, c equals 2 pi r. So c will equal 2 times pi times the radius, which we found to be 145, square root of 145. Sure, thanks. Okay, so sorry, you got 2 pi. You could leave this in exact form, 2 pi square root 145, or you could put this all in your calculator and say, it'd be 75, and let's round it to 2 decimal places, so 0.66. Okay. All right, number 2, we got find the area of the circle, whose diameter starts at -4, 5, and ends at 2, 3, so that's on the circle. So I want to find area, so refresh, area is pi times the radius squared. So if I have the circle and I have a diameter that starts at -4, 5, and whose other endpoint is at 2, -3. Now, that's a diameter. In our area formula, we want to find the radius. So we could do a couple different things. You could find the distance between the two endpoints of the diameter and divide it by 2. That would get you the radius. The other thing that you could do is you could find the midpoint or the center of the circle using the midpoint formula, and then find the distance between the endpoint and the center of the circle. Obviously, shorter steps would be just to find the whole diameter and divide it by 2. So that's what I'm going to do here. I'm going to find the distance, okay, d also stands for distance. In this case, we're going to use it to represent diameter. So -4 minus 2 squared plus 5 minus -3 squared. And we're just going to continue to simplify it. So -4 minus 2 is -6. -6 squared is 36. And 5 minus 3 is 8. And 8 is 64. So then if you simplify this more, you get the square root of 100, which is 10. So reminder that that was the diameter. So then the radius is going to equal 5. So now that I have the radius, I can substitute it back into my area formula, which is a equals pi times the radius, which is 5, and squared. So if it asks for an exact form, you would say 25 pi, because we don't want decimals. So this would be exact. If it asks you to approximate it, you would then take your calculator and put in 25 times pi. So, which is about 78.54. And I'll usually ask you to write 2 decimal places. So that's just a little review how we're going to use the distance formula in relation to circles.